In the past, humans have invented technologies by means of trial and error. Every time a new discovery was made and applied to the fields of technology, huge leaps were made due to each new discovery. The intentional manipulation of particles for the development of materials with specified characteristics is called nanotechnology. Nanotechnology will dramatically improve the quality of life in the near future. In a way, nanotechnology is the converging of theoretical science with applied technology. Scientists are approaching the application of quantum theories in real-life technological applications. This is the point where the level of technology is reaching our level of theoretical understanding of the structure of matter on the atomic level. Misunderstanding of the term nanotechnology. The term was being used to glamorize the production of nanoscale blobs, where actually products such as nano shampoo, DNA perfume, and quantum golf. Technologies using the properties of matter on the nanoscale have already been used earlier. From ancient Rome, the Lycurgus cup looks green when light is shown on the outside, and red when the source is on the inside. This happens because there are nanoparticles of gold and silver inside the glass. This work of art was made the way it is by accident. Photography is an example of nanotechnology. It uses silver halides which decompose to form nanoparticles of silver when light is shown on them. Photography was invented in 1827. At this time, the understanding of atomic structure of matter was in its earliest stages. This technology was developed using trial and error. This was one of the first nanotechnologies to have a huge impact on society. Already in the 1950s, scientists have thought about getting rid of the trial and error in terms of chemical substances and their production. They were looking for opportunities to manipulate matter on the nanoscale. One such scientist, a well-known physicist, is Richard Feynman. "There's Plenty of Room at the Bottom" is the title of a lecture given by him. Feynman discussed the possibility of manipulating matter on the atomic scale. He talked about making the possibility of denser computer circuitry and microscopes, which could see things much smaller than is possible with scanning electron microscopes. He imagined making microfactories, which is a self-regulated system of tiny mechanisms embedded within other mechanisms. This is what we now call nanorobots. He implied that this is possible according to the laws of physics, but as objects get smaller, different laws of physics must be applied to them. As the sizes got smaller, one would have to redesign some tools, because the relative strength of various forces would change. Gravity would become unimportant, surface tension would become more important, van der Waals attraction would become more important, and so on. In order to work on a nanoscale, instruments are required. One of the most crucial instruments is one that will allow us to visually see what is happening on the nanoscale, and more importantly, measure the objects. In 1981, the scanning tunneling microscope was invented by scientists at IBM Zurich. STM can be used in various mediums other than vacuum, like air, water, and various other liquid environments. This represents gold surface under STM. The positions of the individual atoms composing the surface are visible. There were many skeptics that criticized Feynman's theory. They said it was impossible due to the Heisenberg uncertainty principle, thermal vibration, radiation, and other laws. But in 1989, individual xenon atoms were manipulated to spell out the word IBM. Interestingly, the same tools that are used to see atoms can also be used to move them. Modern technology allows us to make something called nanolithography. It also allows us to make beautiful works of art, like this toilet, which can be measured in nanometers. Microelectronic technology companies have been heavily involved in nanotechnology and its production for decades. Moore's law says the number of transistors that could fit in a given area would double every 18 months for the next 10 years. This law has been around since 1965 and is still in action today. Electronic elements of microchips are shrinking every year. At this point, they're about 45 nanometers in size. This is virtually nanotechnology in full bloom. Intel predicts that in 2018, the size of elements will reach 16 nanometers, which is the limit for this technology. Scientists are looking for a way to bypass this technological limitation. A new technology for storing our information could be the use of quantum dots. In the early 1980s, nano-sized crystal semiconductor materials made from the same substance exhibited strikingly different colors. These nanocrystal semiconductors were called quantum dots. A discovery was made that linked the color of the emissions to the size of the nanoparticle. The smaller the nanoparticle, the closer the emitted light is to the violet end of the spectrum. This discovery will allow the creation of microchips without circuitry. The biggest problem of modern microchips is that they overheat because of dense circuitry. Remember that charges undergo more resistance if the diameter is smaller. On the other hand, light propagates at a much higher speed than electrons. This means information will be processed much faster. Q-dots can also be used as a light source. Light bulbs with practically zero thickness have already been made in the lab. If we can also make sources that are tunable in output frequency and can be layered on the nanoscale, then we'd be able to make computer and TV screens virtually painted on our walls. This technology not only looks appealing, but will be cheaper and will reduce e-waste due to the reduced mass compared to bulky computers. Who was the first nanotechnologist? No, it was not Richard Feynman. And it was not Einstein either. Nature is the first nanotechnologist. Another idea that is important for nanotechnology is the ability of objects to self-assemble. This is important because it will allow us to sit back and relax while the nanorobots do all the work for us. Modern scientists are inspired by already existing nano-objects in nature. Some examples are self-assembling DNA molecules, and another example is the ATP synthase motor found in the mitochondria and chloroplasts. Also, our skeletal and cardiac muscles have an efficient form of natural nanotechnology called actin and myosin filaments. These filaments engage in the sliding filament theory. Scientists predict that similar structures and objects can be made using the laws of nature. Carbon, as we know, can exist in the form of graphite and diamond. Graphite's sp2 hybridization allows it to slide off layer by layer, while diamond's sp3 hybridization creates a sturdy atomic crystalline structure. Scientists have discovered new forms of carbon, such as buckyballs and nanotubes. Materials made from these nanotubes are predicted to be extremely strong and lightweight. Scientists are attempting to make a nanotube of an appropriate length to make materials. There are many applications for nanotubes. Some are creation of extra strong and extra fine material. Some scientists think there is a possibility of building a mast so tall it will practically reach space. This gives us an opportunity to launch satellites with minimal fuel consumption and consequently minimal cost. Nanotechnology will benefit economy, environment, and quality of life greatly. Using nanotechnology, we can make super lightweight and sturdy materials for use in the aviation industry and the automotive industry. Such cars and planes will require less fuel to run. Moreover, we can make enzymes promoting complete combustion of oil. This will save fuel and resources, and therefore money. We can also engineer bacteria capable of breaking down garbage. This will greatly benefit the environment. Viruses can be used in medicine to treat diseases with DNA, but they are good only if they are controlled. If scientists lose control of them, they can evolve into a more dangerous species, which can cause real diseases. If scientists lose control of nanobots, they can cause nanopollution, which can eventually turn into gray goo. Nanotechnology can provide us also with artificial food. We will soon be able to even synthesize meat. Such technology can end world hunger with a much smaller effort. And now for the presentation of Dr. Alina.